Good afternoon, 21 minutes after 3 o'clock. This is GB News. We are the People's Channel. I'm NanaAkua. Now, there have been some serious incidents involving extreme turbulence, and 10 people were injured on a flight from Doha to Dublin. And this came after a British man died on board a Singapore Airways flight, which left many more injured. And lots of blame has been put on climate change for an increase in clear air turbulence. But what is really going on? That's the question. It's all a bit worrying. So joining me now is travel correspondent Simon Calder and travel aviation analyst Sally Gethin and also climate scientist Paul Burgess. I'm going to start with you, Sally. Air turbulence. OK, what is it?
So it's basically atmospheric conditions that airplanes fly into, and it can sometimes be caused by storms, by weather arising from mountainous regions, but also there's this type of turbulence you absolutely can't see and it's unpredictable, called clear air turbulence, and that's the type of turbulence that has been causing most of the problems that we're seeing in recent days.
People are blaming it on climate change. I've heard this quite a few times.
Yeah, so this is an emerging science where quite a lot of research has been done already and is looking at the rate of incidents in recent flying history. And so there is, the scientists are saying that given time, there's going to be more and more of this air turbulence. But also we must remember that simply the sheer weight of numbers, there are more people flying, there are more flights. So regardless of climate change, there's more likelihood of, as a passenger, for you to experience turbulence.
Right, let me come to Paul Burgess. Is there any logic to the fact that people are saying it's climate change? You're a climate scientist.
None at all. None whatsoever. And all you have to do is look at the simple data. So could I bring up, I've given your producer graph 2.
Okay,
if you can bring up graph 2.
If we're allowed to have graph 2, let's see if we can
it's very simple, this.
What will it tell us?
It's going to tell you, it's the lower part of the graph here, is the amount of accidents per 100,000 hours.
So that's the black line there.
The black line there. The lower line is the incidence from turbulence on passengers over the years.
From
and there's no
years
pattern there at all. There's no pattern there at all. If it was due to climate change, you'd see it turning up, etc. In fact, it's much lower now than it was back in 2003. So if you look at the data, but what you've got is Reading University produced a paper recently, not based on observations, not based on facts, but based on a model in this little part of the North Atlantic that ignored lots of things and predicted, as they all do these models, it's going to be a disaster in the future. This is a typical taking a weather event and totally distorting.
Where are those figures from?
These are from the, in America, from the FAA. It's a government figure.
What does that stand for? Sorry?
That's the, FAA is the
Federal Aviation
Authority. Thank you.
Right,
Federal Aviation Authority. All my graphs. I've got another table, which is the number of actual accidents on passengers over the years here. Yeah. And I haven't given you that, but if you read it, it's ridiculous. I mean, in 2009, there were 10 people affected. And in 2022, there were 4 people affected. 1, 2, 3. It's nothing.
But these are in a row. Simon Calder, you travel a lot. Do you experience much air turbulence and to the extremes that we are seeing?
What we have seen over the past 10 days or so, particularly with the tragic Singapore Airlines flight, is some really violent turbulence. Now, at no stage was the aircraft at all threatened, even though, of course, it was being hurled around. And I've studied the report so far for the Singapore Airlines event, and the kinds of forces that those poor passengers and cabin crew, remember for them this is effectively an industrial injury, went through was just awful. So for 5 seconds they were travelling downwards at 26 miles an hour on average. Imagine you're sitting there having a lovely time, they're serving breakfast, all very nice, and then suddenly you are dropping down. They had the sorts of G-forces that you would normally get on a really, really extreme theme park ride. So this was awful, really upsetting, and of course anybody who wasn't strapped in and anything that wasn't nailed down started flying around the cabin. Awful, and now Singapore Airlines has changed its policies to say effectively seatbelt signs on, we're not going to be serving any meals and everybody has to stay strapped in. I conducted a social media poll immediately after this event, And there was nearly 5,000 responses. By a majority of 5 to 1, people said, yep, you really should make it the rule that everybody, when they're sitting down, keeps their seatbelt on, just as you would do in a car, for goodness sake.
How dangerous is the turbulence, Sally? Because 26 miles an hour going down suddenly, and, you know, obviously, luckily, the plane was not at risk. But what are the risks if planes get caught in this?
Yeah, so you nailed it. It's a danger to human beings, but not necessarily the aircraft itself. Aircraft are stress tested to withstand incredible forces. But as a human being, yeah, if you're not strapped down, basically anything that isn't bolted down is likely to rise suddenly. Or, in some cases, if the plane jolts upwards, you can be pinned to the actual floor. So, obviously,
jumping upwards is also a turbulence, is that as well?
Yeah, that's also a sudden jolt upwards, sudden rise. And, of course, passengers are likely to experience fractures and injuries where there's a lot of collisions. So you imagine the food trolley, the food and beverage trolley is quite considerable weight. That can take off the same as a human being. So it's literally like blunt force trauma to a lot of people.
Why can't the plane see this turbulence? 'Cause presumably some turbulence you can see and some...
Yeah, they can see certain types of turbulence coming, and they're fitted with equipment to look ahead, and also pilots share data, and air traffic control shares, you know, warnings about turbulence, and they might even plan a different trajectory for their journey based on turbulence. But this clear air turbulence, not enough is known about it. Much more work needs to be done about it. But there's also an emerging science called LIDAR technology, which is a very cutting edge, and that could offer potentially a solution to this.
Paul, does the turbulence move about? Or is there one pocket that everyone knows about and you can avoid it?
Oh, no, it moves about. By the way, I think for the first time ever on GB News, I agree with all the panel here. You know, I really do, because no one's tried to relate it to climate, because there's no connection.
Well, we do keep hearing people saying that, though.
Yes, I know we do. Well, they use any
excuse.
excuse. They say it's climate is, you know, against races, against particular people, and so on. That's all nonsense. I'm here to stop that ridiculous sort of claim. And the data shows there is no movement, there's no pattern to air turbulence. And the air turbulence can be, like if you're going over a mountain range, you can actually get a hole like this. Now, that can actually project you up, just as the lady said, or it can project you down, right? That can happen. That's life. Right. Accept it.
All right. Well, so, Simon, there's no way of avoiding it, really. Then could they get better technology?
Yes, they can.
To see it?
The lady explained that perfectly. You explained it perfectly.
Simon Calder, I'm going to Portugal soon. I want to avoid planes. What would be my best options?
OK, well, you will find it will take about 10 times longer. It will cost probably 5 times as much.
Really?
And arguably, well, if you make the journey, which will take you, if you're starting off in London, you've got to get across to Paris, then you can go from there to, let's say, Hendaye, on the French-Spanish border. From there, you get a little local train across to San Sebastian, then you can catch the train from there onwards to Lisbon. So it's going to take quite a lot of time. It will cost probably about £300-400 as opposed to £50, £60, £70 to get to Portugal. But you know, you'll have an adventure. However, I think the chances of anybody, I hope, being hurt in turbulence over the next few months is extremely low, because people will keep their belts on. And that, I think, we'll see more and more airlines changing their policies to reflect the fact that turbulence is now the most dangerous thing that can happen to you on a plane. I mean, last year we saw no crashes involving passenger jets at all. An amazing record. And now it's clear that actually turbulence is more likely to cause you harm than you being involved in an accident. Wow. So I'm going to keep flying happily, but I'm going to be all strapped in, just like I'm driving along in a car. OK,
thank you. Well, when you need the loo, though, that's the worrying thing. You don't want to be the one going to the toilet. There must be some sort of rope or something they can put on you. Right, let's go to Terry Tozer. Now, he's a retired former pilot and author of Confessions of an Airline Pilot, Why Planes Crash. Terry Tozer, I wanted to ask you about air turbulence. In your experience as a pilot, have you been through a lot of air turbulence?
Well, I guess so. I mean, everybody goes through turbulence on almost every flight to a degree. What you don't encounter is really severe turbulence very often. I've only had one really remarkable event. Nobody was hurt because everybody was strapped in. The aeroplane will withstand quite a beating, And in fact, it's quite ironic, really, because one of the reasons that I wrote my book was because people kept saying, I'm terrified of turbulence. It's the one thing that scares me. And my reply has always been, it's the last thing you need to worry about. The chances of being hurt as a result of turbulence are vanishingly small.
But can you see it as a pilot, as you're flying? Can you see it? Does it look like anything? Are there suspect clouds? I don't know.
Well, it depends. There are basically two causes, as a general rule, of turbulence. One is clear air turbulence, which happens at high altitudes where winds conflicting with one another create a turbulent environment. The other one is to do with convective or instability related big clouds like thunderstorms. If it's a thunderstorm, if a cloud's got moisture in it, your weather radar should pick that up, and so you can usually avoid it. But you can't see clear air turbulence, I'm afraid.
Sadly not. Terry Tozer, thank you very much. That's the view from the cockpit. That's what he's saying. Any final thoughts?
Yeah, there are some things you can do to actually help yourself in these situations. As Simon said, you know, make sure you're buckled up at all times, especially also on a long-haul flight if you're sleeping. But also, there's some anecdotal evidence from flight attendants that people who are flying at the rear of the plane, sitting at the back, tend to suffer more impact than people seated further forward in the aircraft as well. And it goes without saying, make sure everything's safely stowed away, either in the overhead locker or safely under the seat in front of you.
Quickly, so you said it's true. Why is that true? Why is it safer at the front than the back?
It's a leverage. The fulcrum of the aeroplane is around the wings. So if you've got a long lever, if you've got something at the back, you're going to get more movement than near the fulcrum. So fly over the wings if you can, and strap yourself in, and don't go to the toilet. That's the advice.
Just very, very briefly, anybody who's watching who thinks turbulence, I hate it, I'm scared of flying, and decides to drive instead, you are vastly increasing your risk profile.
That's true, but then if the plane's going down, it's going down, and you're vastly at risk of not surviving. That's the difference, I think. But yeah, you take your choices, you make your choices, just belt yourself in, belt up is what I would say. Right, thank you very much, Paul Burgess, also Simon Calder, Sally Gethin, and Terry Tozer. Well, that was our roundtable discussion on air turbulence. Hopefully you feel good about flying now. This is GB News on TV, on 9 and on digital radio. Coming up at 4, my monologue as Grenada demands the Bank of England pay slavery reparations. What are your thoughts? But first, let's get your latest news with Sam Francis.
Nana, thank you very much.